Hello, everybody. Welcome this morning on this Monday. With me, our dear colleague, and I can almost say a friend, hopefully to be. Very soon we meet also in person. Raphael, nice to meet you as always. I would like to introduce to all of you, all the viewers today, Mr. Raphael Schranz. He's a circularity economy specialist at his agency, helping companies and also municipalities develop a circularity roadmap or waste management, waste prevention map for their operations. So today we have a second episode of our talk. And previously we were talking really about, the kind of ways to manage waste or excessive resources for businesses, and kind of how to figure out a way into the future. And there it was always a topic which resonated, which was either circularity or zero waste prevention. So this is also the idea which brought us to this episode today, which is about industrial symbiosis. And it's really like an intro on how the sectors can collaborate to really leverage maximum efficiency on the inputs for production that are being used, and how can we kind of keep them in endless loops, hopefully, for future uses. So with this, I would hand over to you, Raphael. Hopefully that is okay.
Yes, thank you very much, Anna, and thanks for
more details on this. And we also are streaming on Facebook. I see we have some technical issues on Facebook, but let's look at it. We have also a LinkedIn stream on, and YouTube. So if you would have any questions or any comments, just drop us the comments in the chat, and we're gonna come to that questions.
Yes, thank you, Jana, very much for that kind introduction and these kind words. As you have already mentioned, I'm basically working as a self-employed circular economy specialist, and I'm helping organizations through trainings, education in circular economy. I'm also helping them in terms of mapping their resource flows and the strategy planning for future-proofing their sustainability strategy. I specialized on trainings and also for emission and cost reductions through regenerative business practices. And I also worked at the complexity analysis for the European Green Deal through the Shared Green Deal Arena series, where we basically looked at different value loops, different circular loops or circular value flows, and how these value flows basically interact with each other, for example, with energy production, food production, in terms of a circular economy. And I would like to go a little bit into industrial symbiosis today and what that does, what are the benefits, what are the challenges, and how can we actually use a circular economy on a practical, but also on an industrial scale in a city-wide manner. So if that's okay, we can jump right in.
Sounds exciting. I mean.
It is. It's going to get a little bit complex, but I think you all get it, so no problem.
Yes, I always have this picture of the circularity scan of Glasgow, in front of me. So when you say complexity, I'm pretty excited to see your presentation, and to share your perspective on things, because it's always very, very useful when we talk about waste management. Just let us know once you're ready with your screen, if you're sharing something from your side.
Can you share the picture, or should I do that?
For sure.
Okay, great.
Hopefully you can see it well.
Yep.
Let's make it a little bit bigger. I think that's...
Okay, great. Can you do the full screen maybe in that picture?
Let's try it. I think that's the best it gets.
Okay, I think that's a little bit small. Maybe I can share my screen as well. I have a little bigger picture there. So let me just. Let me just try that.
Okay, cool. We see
Okay.
that.
I think that's a little bit bigger, right?
Oh, yeah, perfect. Better
Okay.
resolution for sure.
Yeah, great. Yeah, so I wanted to go a little bit on, I wanted to talk a little bit about industrial symbiosis today and about the circular scan of circular economy that they did in Glasgow, where they basically looked at different value loops. So we can see here that these value loops are referring to three different kinds of industries. So first of all, we have bakery, then we have meat and fish production, and then we have beer and spirit production. So we can see here three different brackets or three different rectangles, basically, where all of these loops go out and in, right? So I think it's a little bit complex at first, but we will go into that. So we're gonna dissect that a little bit so it gets clearer and clearer. So in general, let's start with the bakery. What we can see here is that we have some input materials. Right? So first of all, this square here is basically the input materials that we're basically sending into this production system, right? And then we have in this square here is the output. So we're basically using some materials, we're basically using energy, we're using water, we're using biomass here in green, which is, I think, very important to mention. We have minerals here in purple, and then also we have metals here in black. Okay, so basically what we're doing in a bakery, of course, for example, we're processing and we're producing bread, for example, which is called biomass in general. And you can see here that these different flows are actually going into the company. Now, the thing is that all of these different inputs and what industrial symbiosis basically wants to achieve is actually have certain inputs and basically use outputs of a given system, in this case the bakery, for example, in terms of waste or byproducts, and then use that as input in another system. So the input basically becomes output, and that output wants to be integrated through different value loops or through different structures, and we want to reintegrate these flows back into other production systems, for example, in the system meat and fish or beer and spirit production. Now, if we look at these flows that actually are output of this given system, so for example, we have food waste that is basically output of the bakery, and then we have different loops. And first of all, we're going to focus on different value loops that are reintegrated into the same system, right? So we're not going to talk about the other systems. We're first of all focusing on these smaller loops and how they're reintegrated into the bakery itself. So first of all, we can see here anaerobic digestion, right? So food waste can actually be used, for example, through anaerobic digestion to not only produce, first of all, biogas, which is basically can be reintegrated into the energy production here. The biogas is actually a middle step because we can also produce compost, for example, with these food waste, right? Another example, for example, on how we can actually reintegrate these value loops or reintegrate these output flows is basically, for example, into heat recovery, right? So we can see here that loop that goes out here, that output that is generated here in this system is being reintegrated as heat recovery into the energy system. So not only can we use food waste for compost and biogas, but also to produce energy. Now, on another note, and now it gets a little bit more complex. Of course, we can use composting, or we can also use biogas and heat recovery, of course, for another system, right? So we're going now into a different system where, for example, these food wastes, we can see here this loop is a little bit bigger, and it actually goes out of the system and basically is reintegrated into the biomass production of beer and spirit production. Now, this is an example, and this is an example for how food waste can actually be dealt with in a different system. So we're reintegrating that here. And also we can, of course, use heat recovery. When we follow this cycle here, we can also use that, for example, in the energy production in the meat and fish industry. Now, we can also use heat recovery for a third system, where we basically are producing excess heat in the production facility of a bakery, for example, and then we're reintegrating that into basically beer and spirit. They're also into the energy production. So I hope this is a little bit clearer. So we went from very small loops, basically localized loops that are reintegrated into the same system, back to bigger loops, which are reintegrated into another system. Of course, we can do that same for meat and fish production, right? So we have these different value loops or different input materials that we're actually using in the meat and fish industry. And then basically what we want to do is, for example, reintegrate these flows basically back to produce maybe mushrooms or algae, for example. We can also use these loops that are here, and all on the biomass front and on the food production that is actually, or the food waste that is actually created. We can also reintegrate that into the bakery. Right? I'm always talking a little bit more in detail about the biological flows, because the biological flows in general, they have the highest potential for circularity, right? So food, for example, food waste, spirit or beverages, they are more easily integratable into new production systems. So with technical materials, it's a little bit more tricky. You need a little bit more equipment for that. But I think this is also very important for the viewers to bring home that biological materials are actually pretty important for industrial symbiosis. And also what I wanted to say here, this is why I'm actually also really an advocate for circular bioeconomy. Circular bioeconomy is a pretty futuristic topic, but I think if we want to have a real functioning circular economy, we need to have that and base that circular economy on biological materials and not on fossil fuel based products. So these things, of course, that looks a little bit complicated, but I hope I brought that across and simplified that a little bit. Now, on another note, what does that do, right? So what does it actually bring for resource efficiency, waste reduction, cost savings, and all of these things, right? So a little bit about the benefits of industrial symbiosis. So of course, we have increased resource efficiency, right? So it basically optimizes use of resources. It utilizes waste. It utilizes byproducts from one industry as raw materials for another, right? So the thing here that people always say is one man's trash is another man's treasure, right? So you want to use waste or byproducts in a way that other people might need that for other system, right? Of course, if we talk about that, then this also minimizes need for virgin resources, right? Because you don't actually have to extract all of these primary resources. You can basically use waste and substitute those primary resources for waste that is generated already. So it reduces overall consumption, right? Waste reduction, of course, is another big thing. By sharing these waste materials, they, of course, significantly reduce the amount of waste that is sent to landfills or to incineration, which basically diverts all of these wastes from landfill and basically also reduces emissions and other greenhouse gases, for example, methane, that are associated with biological waste that would normally be on landfills, for example. It also diverts waste from water bodies. So I think waste reduction, emission reduction is, of course, also a very, very interesting benefit. Cost savings. Through industrial symbiosis, of course, businesses can actually save costs on waste disposal because they don't actually have to dispose that waste. They can actually either give it to another system, another company, or they can even charge maybe for that, which actually transform these waste disposal costs into an income stream, right? So they're reducing also procurement costs. They're reducing energy consumption through this reintegration of these different flow in other energy systems. And of course, these cost savings, they improve overall financial performance of the company. Innovation would be another. So by collaborating with different stakeholders, with different systems, of course, innovation happens, right? So people in different industries can actually work together, find new solutions, find new technologies, to repurpose materials, to improve production processes, or in general, develop completely new products and services so that industrial symbiosis functions even better. Energy efficiency through the recovery of that excess heat from one production system, you can also, of course, reduce your energy needs, right? So sharing energy resources like heat, steam, and among industries, they can actually lead to drastic energy efficiency gains, right? They reduce greenhouse gas emissions that are associated with energy production, and also through that, they're contributing to climate change mitigation efforts, right? Job creation is another. These symbiotic networks, or these symbiotic value loops, can actually increase jobs, right? So there are new opportunities, for example, for recycling, for material processing. You need logistics systems for that. You need transport to actually transport these different materials to another system. And of course, this creates job. And the interesting thing is that it creates job in not highly qualitative sectors, right? So people don't actually have to be highly qualified to do these jobs, right? Which I think is very, very important if we talk about it, Industry 4.0 technologies and the fear that actually technology replaces a lot of jobs. This is actually where a lot of these jobs can be created. So the circular economy really also brings that job creation element, which I think is massively important. Local economic development. So through these localized value loops or through these symbiotic networks, it basically creates localized and decentralized value hubs, right? So it promotes inter-industry collaboration, it attracts investment, and overall reduces transport, it reduces fuel consumption. So it localizes all of these currently global systems. It localizes them into very, very small production and consumption loops, which I think are very, very important for the future. This is also a very fundamental thing of the European Green Deal. And this overall increases resilience. It fosters local supply chains. It it decreases single point of failure risk that we're actually seeing in today's global supply chain. So localization and decentralization for economic development is also quite the benefit. And of course, not only are there just benefits, but also there are, of course, challenges as well, right? So if we look at this structure, there's complexity involved, right? So to actually build all of these loops, you have to have coordination with different stakeholders. These structures are not easily built. You need time for that because they're very complex. You need to assess what materials are actually in the production system, one, to basically reintegrate them into another production system, two. So you have to do an assessment on those materials. Regulatory hurdles, for example, would be another one. So existing frameworks or policies might not always support these exchanges of waste materials between industries, which poses a challenge. I think regulators need to keep up there a little bit. And of course, there are some others, but I think in general, industrial symbiosis are a very interesting thing for the future, very important for practical implementation. Other barriers, for example, would include logistical challenges. So of course, you need transport for that, but for that transport, you actually need fuel. How do you actually base these fuels on, right? Or can you use hydrogen already? Do you have the manpower to actually implement these logistics systems? Market dynamics, price fluctuations are, for example, one additional barrier. And of course, cultural barriers. People might not always agree with each other. They maybe have different cultures, different goals, different priorities, right? So they have to really find these common grounds for collaboration. Investment needs to be done. So we're not going to snap with a finger and basically have all these value loops. We need investments in transport and logistics. We also need investments in research and innovation. We need scientists for that. We need people who actually do these scans, right? So investment is always critical. Funding is always critical, although it's even harder today because a lot of global markets are currently drying up with liquidity. So there is not a lot of liquidity that is remaining in global markets. So investment is a big one. And of course, risk management in general, these symbiotic relationships, they often create also disruptions, right, for currently existing industries or for currently existing structures that exist in a certain region. But yeah, so a little bit about those risks. But in general, as I've stated before, circular economy and industrial symbiosis, as a practical example, for a city, it really combines the sustainability aspect in terms of environmental protection, but also economic development and also social cohesion, right? So we always want to integrate all of these three different dimensions into our sustainability strategies and also in our regenerative business strategies. So I think it's a pretty interesting and pretty powerful tool and a pretty powerful closing strategy for the circular economy, industrial symbiosis. So waste reduction, which is the environmental part, emission reduction, cost savings, which is the economic part of the sustainability parameters, and of course job creation, which is also very good for social cohesion and underlying social networks. Yeah, thank you very much. I hope I did that very, very understandable. I know it was a little bit complex at first, but I hope I could get that across, what the benefits are. And yeah, so open for questions now. I'm gonna just share, stop sharing my screen there. Okay, great. Yeah, it should work.
Great. Thanks, Raphael, for the amazing presentation and explanation also of the industrial symbiosis and the approach over there. So when looking at the picture, especially, I mean, there are 7 questions we have at least, so let's be fast. We have 8 minutes to go. So it looks like a lot of coordination. So these were literally the picture that you introduced. These were 3 businesses. One was a bakery, one was meat production, the other one was, if I remember that correctly, a brewery. Yes. So how can businesses find these potential collaboration partners? Are we in the stage that, especially because you work with businesses, maybe, to start from there, in which stage are we? Are businesses looking already at ways they can do things for the future, start to kind of align, look for their potential partners? Because this looked like a lot of coordination that we will have. This was 3 businesses. Now let's imagine a city. You have, 20 companies, 30 companies, different scales, geographically also kind of, concentrated. Where are we right now to go into the industrial symbiosis in the future?
Yeah, so I would say it's still early days, right? The underlying structure of doing business like that is very, very new, right? So circular economy really focuses on these partnerships and really bringing together all of the stakeholders that are involved, right? And in the last 20-30 years, that has not always been the case, right? So we're of course talking about a different mindset shift where people really have to come together and really focus on solutions that basically benefit everyone involved and basically solve problems for everyone, right? Because we're talking about economic problems, we're talking about environmental problems and social problems. So everyone should be interested in fostering these partnerships because it's mutually beneficial, right? So symbiotic relationships are important, and it really speaks to the fact that we're basically we have to go a little bit back to natural principles. So what we basically want to do is mimic natural principles that we see in the natural world where these symbiotic relationships exist, right? So we're a lot talking about the circular economy, but what we're also not talking about a lot is that basically we need to return to nature a little bit, right? We need to have these connections to natural things again, and look at how these symbiotic relationships actually work in a natural world. And that's what we're actually doing with industrial symbiosis, right? So we want to mimic the natural systems. So that's also called biomimicry or bionomics, but these partnerships are very important. So in general, very, very important for the structure of the industrial symbiosis. Yes, so you need every stakeholder involved, and they have to work together. Yes.
Wow. So it's like a new level of collaboration that we are kind of facing. And allow me just, a few more questions, because it's always such an interesting exchange with you on this topic. And, I really appreciate you sharing also the expertise that you have gained in your previous time, helping within the realms of also shaping frameworks around waste management. So, when we talk about zero waste and waste prevention, what would be kind of the key differences between these two approaches that you would like to maybe share with us?
So waste prevention is always number one, right? What we're talking about here is basically using waste and using byproducts and different production systems, basically reintegrate them into other systems, right? Of course, waste avoidance is even better, right? So that's on the waste hierarchy. That's very high up on the waste hierarchy. It's actually the first thing, right? So in a circular economy, is the first principle that we want to eliminate waste through circular design, which is basically waste prevention through circular design, through durability of products, highly durable products that we can basically share and reuse in multiple cycles, for example. Longevity and repairability of products, for example, so that we can actually repair them so that they don't become waste, right? But of course, that's far off in the future, right? Because currently we have these waste streams and we need to do something with them, right? So we want to reintegrate these waste streams currently as best as possible to be used in other systems. And of course, the overall goal is to basically eliminate this concept of waste through circular design. But industrial symbiosis actually also avoids waste, right? Because it's a closing strategy. Yes, the waste is being generated, but it actually avoids waste through the implementation and through the reintegration into different systems. So it's a middle step that we want to do with the waste that we're currently creating. We want to use industrial symbiosis to reintegrate that waste to avoid waste, right? And then in the future, we want to avoid waste through circular design so that waste is not even generated, right? So I think those two things, eliminating waste through circular design choices for products and services, is far off into the future. But industrial symbiosis is a thing that we can do right now.
So this is amazing. That's amazing news. Also, like a key takeaway, industrial symbiosis can be done today. People look at the partners who you have in the neighborhood. Maybe you can work together on minimizing your costs for electricity and what you have. We saw there a brewery. There are also some nice examples of such collaborations where, for example, bread waste is taken for brewing of beer in Netherlands. I think in Czech Republic we have also some examples on that.
Yeah.
So quite interesting possibilities. And also looking at you mentioned circular bioeconomy, something that we hear more and more about. How, because this was really technical, it was really on the sector, on the industries, so really like industry based. Where does regeneration and the bioeconomy come into the game? You said let's connect to nature.
Yes.
Let's mimic it. How else can we integrate it? What else would you see for businesses or for cities to kind of
Yes.
really
So
live it?
when we talk about the circular bioeconomy, we always talk about, for example, biogas production, right? So if we have biological materials, through the decomposition of these biological materials, you can produce biogas. With that biogas, you can produce electricity. You can use that excess heat in the biogas production to reintegrate that, and you can also use that for composting, right? So what we currently see in today's economic systems or global economic system is soil nutrient depletion, right? So For example, we're using a lot of artificial fertilizer, right? We're adding fertilizer into our soils and then basically produce something, then basically we harvest that, and then basically soil nutrients get depleted, right? Then we have to add even more fertilizer, right? Basically we then produce, we harvest, we sell, then soil nutrients deplete even more, right? So it basically creates this self-destructive spiral downwards, right? It's very unhealthy for the soils because it really depletes the nutrients in the soil because you're always in this vicious cycle downwards, right? And through the reintegration of biological materials, you can basically start composting again on a massive scale, right? Which basically would provide material or highly nutrient material that you can actually add to soil, right? So you can actually replace or substitute artificial fertilizer for example biochar or biological fertilizer that you can actually use for those soils. And basically you then you reduce the need for artificial fertilizer, right? You then produce, you then harvest, you then basically reintegrate through composting again, and then basically increases the nutrients in soil, right? So it actually creates this regenerative spiral upwards, right? So there is a reason why composting works, and there is a reason why we actually have to make sure that we're not using this artificial fertilizer in excess, right? In very, very high amounts, right? Because this creates the spiral downwards. And with composting, for example, with the use of other biological materials, we can actually produce biofertilizer, we can produce biochar, we can produce biogas. So biological materials in general are really, really versatile and really interesting for various aspects, right? So this is, I think, that where the power of nature actually comes in, right? Where you can actually use all of these food wastes, which you would then basically divert from landfill. So it's basically a multiple win-win situation, right? It decreases waste, it decreases emission, it increases soil health, it increases biogas production for electricity consumption. It is possible to produce biochar to make a living for people. It's possible to produce biofertilizer to increase standard of living for people. So there are multiple wins in my opinion, and that's very, very powerful for the future. Of course, we're talking about different materials that we can actually use in terms to replace plastic, for example mycelium. We can use algae in the future, we can use bamboo, we can use hemp, for example, industrial hemp. So there are a lot of different materials that are actually very, very interesting for the future. And yeah, in general, this is why I'm actually so fascinated for the circular bioeconomy.
Absolutely, and definitely share this passion with you. That's why we have always a kind of interesting exchange on that. So we talk also a lot about the future and what is possible now and what is maybe a little bit later. And you see some lighthouse approaches when we talk about zero waste, even in cities or in municipalities or communities. But there are also other solutions that we have right now, for example, like waste to energy, that are, right here, right now. We have a lot of, sensors or collection methods and a lot of IoT solutions, digital solutions that help us manage the way we work with waste right now. Now, when we are like doing a little roadmap here for waste, as everybody's used to this term. I mean, those of you which are in sustainability, maybe you don't like this term at all, and you would rather use maybe excessive material or something. So, however, for the common understanding, let's just use waste. Where are we when we should, make this card on how the journey goes or should go, and having zero waste with optimal circular design as the destination? This is how we will do things in, I don't know, 5-7 years. Let's be ambitious. What are the steps? I mean, where do you see maybe current solutions? Like you mentioned landfill. We still see them, kind of growing. Incinerators, many times also a topic still we have now, this waste to energy. Many times there is also a perception, this is, a ticket to continue, all good, we're just going to convert it. What do you see as the approach, as the road? How will it go according to
Yeah,
your
so there are multiple things that need to be done, right? I mean, when we're talking about the circular economy, what we're really talking about is basically a complete revamp of our entire global economic structure, right? So what we're really talking about is changing the economy on an industry scale level, right? So the current dynamics is our world is 7.2% circular, right? So over 92% basically is created as waste, is being created, is sent to landfill, is sent to incineration, is sent into water bodies. So basically there's a lot of material and a lot of waste that is still being created, right? So there are multiple things that need to be done. First, we need to have circular product design, as I have mentioned, because the design phase is very, very important. Design products in a way that they don't actually become waste, right? Through durability, longevity, repairability, modularity, upgradability of products, and all of these things, right? Then we need different business models. We need the sharing economy where people basically share different things with one another, highly durable products, and share them, right? For example, alternative regenerative business models where we can actually use different methods for the circular economy. For example, to slow, narrow, and close resource loops, there are different business models where we can actually slow resource loops and basically have performance-based business models. So, for example, car sharing is one good thing, right? So that's coming. So the sharing economy, the performance economy is coming. Basically, people are going to pay for the performance of a product in the future. If they don't need it anymore, then basically the liability stays with the production company. That creates a liability loop, which is invisible. So it's a little bit hard to understand, but it basically creates this liability loop. After the useful life of a product, or after the people don't need it anymore, the product basically comes back to the company. The company makes sure that the product is, for example, in terms of car sharing, the car is insured, that the car is clean, that the car functions properly, and then basically rents it out again, right? People pay for the kilometers that they drive, and then basically the car comes back to the production company again. We of course also we have different speeds on circularity, right? So for example, waste management systems does not even exist in different countries, right? So we need functioning waste management centers. We need technology. For example, if it's not possible to basically teach people to separate their waste, then basically we need, for example, AI-based vision systems that can actually separate these waste streams as they occur, right? Basically sort them into 98% purity, for example, and send them back into production. Technology, IoT sensors for bins, AI-based route optimization, so blockchain-based systems, for example, to track and trace materials over their journey, right? And even after their useful life. So yeah, QR codes are coming, where you're going to have basically real-time insight into all of these supply chains. You will know as a consumer in the future where, for example, your fish was caught, under which conditions they were caught, under which conditions the laborers were, who transported, who got paid, who was insured, basically how was it stored, under which condition was it stored, did the people get paid. So you're going to have real-time insight and real-time transparency for all of these production stages to actually verify all of these things that you're eating, for example, that actually those claims are true that companies basically make. And yeah, so IoT, AI, blockchain-based systems, and of course, a mindset shift that we need in terms of going away from being consumers to basically being users, right? And to basically not mindlessly consume things that harm you, right? So refusal would be a big one, right? So there's a lot of things that people can actually accomplish themselves if they simply refuse the things that harm them, right? That would also decrease the amount of waste they're generating, right? So mindset shift, psychological mindset shift, technology implementation, waste management implementation and decentralization of waste management systems globally, implementation of, first of all, biological reverse logistic flows to basically decrease the amount of waste that is generated for food waste, for example. If we talk about, for example, in Nigeria, there's 50% food waste, right? So with the reverse logistics for biological waste streams alone, you can basically decrease the amount of the waste in Nigeria that is produced by 50%. That's massive. That's a start, right? So yeah, there's a lot, right? So we're really talking about multi-dimensional problems where you need a lot of different regulators, technology, different business models, and all of these things, and they have to work in tandem to basically do that. But that's why partnerships are so important, right? So work with regulators, work with the companies, work with consultants, work with trainers, with coaches, with people around the world, with people in agriculture. So my network is pretty diverse, right? So I'm working with people in agriculture, manufacturing, in IT. So you basically need a lot of input and a lot of knowledge and different things. Yeah. So I hope that answered your question, but it's it's a lot. Right?
Mm-hmm. It's a lot. It's a lot of work as well. And no, for sure, and absolutely agree. So, and also looking or going back to this circularity scan. So, how can companies or municipalities get to this? Can you eventually or your company help them to create a circularity scan?
Yeah, so I'm doing a mapping process for companies, and also if it's required, then I would also do that for cities. Of course, that would massively increase the complexity, but of course, I'm doing mapping processes for companies. So I'm basically look at what are the materials that are going in, what are the processes that are involved in this company, what linear processes do occur, and then basically look at what is the systemic leakage of this system, and then basically help these companies to basically transform these linear structures into circular ones to not only achieve emission reductions, but also achieve cost reductions. So that's my goal, is basically make environmental protection economically viable, right? So basically bring that down to a business level. And of course, I'm helping them with mapping services. I'm also helping them with consultancy services on a longer term partnership to basically help them in their journey. Because if you have to transform your processes, that's not going to be easily done in half a year or maybe 2 years. It also depends on the size of your company. So such projects for very large companies take 5 to 10 years maybe, because there are a lot of different structures that need to be changed, of course. But yeah, so that's what I'm doing. Yes, so I'm helping them with trainings, education, mapping of their resource flows, circular resource mapping, and of course strategy planning for the future to really help them on their journey. Yes.
Thank you so much, Raphael, for your time today, and thank you for the great session. Let's keep in touch and let's follow up on the next session. I see you in the next one.
Yes, thank you very much, Anna, for having me. Really, really good conversation. Take care, everyone, and wish you all the best.
Thank you.